Hey guys, and welcome back. So now we're going to take a look at another option inside the flip fluid, and that's going to be the detect droplets option. And what this does is, if a particle density is between this range, it's going to be flagged as a droplet, and then it's going to behave differently. It's basically going to have less fluid effect on it, and it is gonna drag and slow down. And we can tweak this to be very aggressive, so that whenever a point gets separated, if we set this, let's say 0.05 and 0.01, any point that separates is going to be flagged as a point, as a droplet, and it's gonna behave differently. If we increase this, then points are not going to be easily flagged as droplets, and even points that are very far away from each other, they're still going to be considered as part of the main sim. And so we have to be careful with this, because if we set this value very low, we're going to start converting a lot of points into droplets, and that's going to create a lot of fuzziness in the sim. If we increase it too high, then we start including points that are too separated, very far away into the sim, and that's going to be tricky to mesh. I also wanted to do a quick test. I'm going to create a grid. I want to show how we can do this density thing in SOPs, and I'm going to create 100 points, and I'm going to randomize them, maybe 50, and I'm going to use a point replicate. I'm going to set it to a circle, and the circle is going to be in the Z and X. Let's increase it. I'm going to add noise to it. Something like that. And so now we have points with, let's actually transform this to 0. So we have points with various density. We get these points there, and let's increase this to 1500. So yeah, we get points that are overlapped on top of each other, and then points that are separate. And I'm going to use a point VOP, and with this point VOP, I'm going to use a point cloud. Let's see, neighbors. What's the name of the function? Neighbor count. No. Point cloud. Find radius. And we're going to use point cloud find radius, and what this does is going to return a list, an array of points, of IDs for each point. So this one is going to get the ID of the neighboring points based on the radius that we're going to choose. So I'm going to connect this to the first input, and that's the file name, and then the point position is going to be the point position. And I can't do much with this, so we're going to use an array length function, and then export this. And let's take a look at the range. You can see the value goes between 10 and 1. So let's put down a fit range. So the input min is 1 and 10. And you can see now we have black points here and white everywhere else. So this is the density value. Okay, in the case of flip, that point is going to be considered as a droplet, everything else is not. And then we have the search radius. If we lower this, it's going to be it's gonna have a smaller region or a smaller radius, and everything else now is going to be considered as droplet based on this density attribute. So all these black points are going to be droplets, and let's separate based on this density value. I'm going to say at CD is higher than 0.5. I'm going to delete the points and then delete non-selected. So this is going to be considered as a droplet that has a value of 0.5. okay, its density is less than 0.5, and here everything else. So you can see already we're getting this nice pattern where everything is connected together. And then let's put down a color node. So these are the points that are considered as droplets, and this is the core of the scene. So that's basically what's happening inside the flip solver. It's using the density. And I'm going to do a test with various values for the min and max, and because if a point is considered as a droplet, it's going to behave differently. Okay, it's going to move differently, and it's going to have a different velocity advection, and we're going to see the effect of varying the min and max on how the sim looks like. And I've already run the wedges and did a preview, and we're going to take a look at that in the next video. Thank you guys for watching, and see you in a bit.